Hey guys, what's up? This is Programming in Objective-C and I'm Yari Dareglia of Jam Zero. Today I show you how to use blocks, a really interesting feature of the Objective-C language. So let's begin this lesson. What's a block? Unbelievably, a block is a block of code. Through blocks we can pass along rows of code like any other objects. And yes, it's something similar to a function, but as you will see, it has some interesting and powerful features to speed up and simplify your code design. We define a block through a special character called caret. Then we open curly brackets and we write our code. For example, we define a string variable called name and we print its value through the nslog function. In this case, we can see a block as an anonymous function, but how to use it? We have two ways. The first is to use the block directly as a method argument, and the second is to assign a block to a variable and use this variable to refer to the block. So let's start with the latter and define a special variable to host the block. As I told you, a block is similar to a function, so for a block we could have a return type, a name and arguments. The block we have previously defined doesn't return value and doesn't need argument. So let's write this variable definition. This line of code tells us that myNameIs is a block that doesn't return a value, and you get this information by the first void. And then it doesn't need arguments, and you get this other information by the void enclosed in the parentheses. So we can use our previous definition to valorize this block. Now we can call this block by myNameIs, just like calling a C function. What if we want to create a block that takes arguments? Well, first we have to change the block implementation. Let's remove the nstring star name from the previous block and request it as argument for the block instead. After the caret, we have to define the argument list like for any other function. So let's write caret, parenthesis, and a string star name. Now we have to change the block variable to fit this new block. So we'll write void caret myNameIs and a string, and then the code for the block. And this time the block variable says that the block doesn't return value but needs a string as input. So we can use the new block definition. To use this block we write myNameIs at, and for example, Mark, and the new code will be executed. Okay, this is nothing really new for you. I mean, from this point of view, a block is something really similar to a function, nothing more. Let's see some other features that make block more interesting. As I told you before, we have two ways to call a block. I've just shown you how to use a block by its name through a variable. Now, I want to show you how to use a block as method's argument. Let's create a new command line tool project and add a new class. Call it myMath. So let's add a method to this class that uses a block to perform calculation on a number. We want to create a proxy function that takes a number and modifies it using a block. It returns a float, which is named modifyNumber, and takes a float as first parameter. The second argument is a block that returns a float number and takes a float as argument. So let's write it this way. Don't be scared by this definition. This prototype is in fact defined as any other prototype you have seen so far. Just take a look at the content of the parentheses for the second parameter. They simply contain a type, like for example an integer. But this time we are going to write a prototype for a block that is a little more complicated, and then we assign the argument name. To implement this function, we move into the .m file and write the prototype. Now we said that this function will act as a proxy that takes a block to modify the float contained in the first parameter. And this operation is extremely simple. You just have to call the block using the number as parameter, this way. Return block and number. As you can see, at this point we don't know how this number will be modified, because we just know that this operation will be executed by an external block. So we have created a really dynamic function. Now let's execute it. Move to the main.m file import myMath class, and initialize an instance, using the alloc_init way. Okay, let's separate the next code in two steps. First, creating the block, and the second, executing the function with this block. Let's create a block to perform the square operation. It returns a float, it's named square, and it takes a float. Now, in the implementation we don't need to define the return type, but we must add the caret and the parameter, in this case a float. And now we perform the operation and return the value. Perfect, we have the block. And now we can pass it through the proxy function. We store the result in a float number. We send the message to the myMath instance using 10 as first parameter and the block we have just created as second. We can use the nslog to verify the result. We can also pass the block implementation directly to the function parameter, this way. And then remove the previous definition. This is a really common practice. Another cool feature of blocks is the ability to use variables defined outside the block. Let's create another operation for the function proxy. Let's say we want to create a sum operation. We can create a float variable like float value equal to 21.5, and we modify the block code this way. Return number plus value. We are using a variable defined outside the scope of the block, and it works great. This adds more flexibility to the use of blocks. Careful though, because this variable is read-only, so you can't modify it within a block. To edit this variable within a block, you have to inform the compiler about your intention using the keyword __ block. So we can add a bool to check if an operation is done, writing __ block bool operation done equal to no, and modify its value with the block code operation done equal to yes. And obviously after the block execution, operation done will be equal to yes. Okay guys, this is only an introduction to blocks, but it is a good starting point to understand why they are useful and how to use them to write what I like to call dynamic code. This is all for this lesson. Hope you have enjoyed it. Next time we are getting deeper into core foundation classes. We'll take a look at NSObject, NSString and many others. Bye and thanks for watching.